Hello, this is Scholastic Sam. Welcome back to my YouTube channel. Today in the class of trigonometry, on the topic of conic sections, we will be talking about hyperbolas. Now, let's start with the equation. The equation for a hyperbola is x minus h squared over a squared minus y minus k squared over b squared equals 1. Now, the center, as usual, is h comma k. Now, here, this part's a little tricky. In an ellipse, you move a and b. A and b can be either on the right or left, depending on the orientation. A is always under which one it's oriented. It's the same in hyperbolas, but instead of moving the a and b, you move the x and y. For example, if it's horizontally oriented, x minus h squared will be on the left over the a squared. But if it's vertically oriented, y minus k squared will be on the left over the a squared. Whichever way it's oriented is on the left over a squared, and whichever way it's not oriented is on the right over b squared. And the transverse axis, which is the axis it'll be on because x minus h, it's horizontally oriented or vertically oriented. That depends on the transverse axis. It's either vertical or horizontal, and it connects the center, the vertices, and the foci. For example, if they're all going like this, it's vertically oriented. If they're all going like that, it's horizontally oriented. Now, one way to remember this is the center, foci, and vertices. If they all have, if the y value between them changes, it's vertically oriented, but if the x value changes between them, it's horizontally oriented. So whichever way it changes is its orientation. Now the a distance is, of course, the distance from the center to the vertices, and the b distance is the distance from the transverse axis or the vertices to the asymptote, either straight up, down, or left or right. So if a hyperbola is vertically oriented, you draw the asymptotes and you take one of the vertices and you draw either straight left or right. They're going to be the same value. And let's say you go straight left, because straight left and right is going to be the same amount. If you go straight left, the distance from the vertice until you get to the asymptote, that's the b value. But if it's horizontally oriented, you do the same thing, just it's up or down. Let's talk about the other parts of the hyperbola. The foci are the center plus or minus c, and depending on the transverse axis, you either add and subtract c to the x value or the y value. Remember, the foci are on the same transverse axis as the vertices in the center. So it's either going to be vertical or horizontal. Now let's look at the asymptote also. The asymptotes, because the asymptotes they're normally diagonal, and hyperbolas are normally diagonal lines, and there are two of them, and they help us graph the hyperbolas and define, of course, where they are, because asymptotes, they always get closer to the asymptotes, the hyperbolas, but they never quite reach them. The equations for the asymptotes are y equals k plus or minus b over a times quantity x minus h. But it's only k plus or minus b over a if it's horizontal. You'll switch b over a with a minus b if it's vertical. So as we've seen, a big part of these graphs is identifying whether they are horizontal or vertical. So what do we need to graph it? We need the center. We can either take the center of the foci or the center of the vertices, because it's going to be the midpoint between them is going to be the center. The vertices we can find based on the center and the a value, but we also need the orientation, because we know that we take the center plus or minus a, but do we do plus or minus a to the x value or to the y value? We need the orientation. So the orientation, you find this based on the line of the foci and the major axis. Like we said, whichever value changes between the foci, the center, and the vertices, if their x value changes, it's horizontally oriented. If their y value changes, it's vertically oriented. Now the center, if the asymptotes, well, we just went over that. You need the a value, the b value, and the center, because it's y plus or minus b over a times x minus h, but it's b over a if it's vertical, or b over a if it's horizontal, a over b if it's vertical. Now let's look at two very important equations. Now eccentricity equals the c value over the a value. Lots of times you'll be given something like the eccentricity and the c value, and you have to rearrange that to find the a value. Now also, a squared equals b squared plus c squared. So this is important. it's not minus c squared like it was in ellipses, it's plus c squared. Let's look at equations and graphs. First, let's use the graph to find the equation, and then we'll reverse engineer it. So first thing we notice, going up and down, it's vertically oriented. And also, we're given a foci are at 3, 0, and 3, 8. So we know that we see the center, the x value of those is 3, and the center is 4 of the y value. So the center is 3, 4. So we already know the h value is 3, the k value is 4. And we can see here that the vertices are at 3, 7, and 3, 1. So the distance between the center to the vertices is 3. So A is 3, because that's the distance between the center and the vertices. So we see that the foci are at 3, 0, and 3, 8. The distance from them to the center is 4, and the distance from the center to the foci is our c value. So we know our c value is this 4. Now we have to find the b value, but we don't have the asymptotes, and it's kind of hard to find the b value just looking at the graph. So we're not really going to practice that, because normally teachers won't give you a problem in which you have to do that. So we know we'll just use c squared equals a squared plus b squared. C is 4, 4 squared is 16, equals a is 3 squared is 9, 16 equals 9 plus what? 16 equals 9 plus 7. So b squared is 7. It means b is the square root of 7. So our equation is thus y minus 4 squared over 9. The y part comes first because it's vertically oriented. The x part would come first if it was horizontally oriented. Our equation is y minus 4 squared over 9 minus x minus 3 squared over 7 equals 1. Now let's find the asymptotes. We know it's y equals k plus or minus a over b, not b over a. It's vertically oriented, so we do a over b, quantity x minus h. Now 4 is k, b is square root of, or a is 3, and b is square root of 7. And do x minus h is 3. So we get y equals 4 plus or minus 3 over square root of 7 times quantity x minus 3. But you can't leave a rational in the denominator, so you have to multiply the denominator and the numerator of 3 over root 7 by root 7. And we get the equations of our two asymptotes are y equals 4 plus or minus 3 root 7 over 7 times quantity x minus 3. Now, when I say quantity, it just means times everything I'm about to say is in parentheses. You wouldn't say times x minus 3, because then they wouldn't know is minus 3 within the parentheses or not. So you say quantity x minus 3. Okay, now normally you would separate these into into the equation with 4 plus the rest and 4 minus the rest. And you put it into you may have to put it into y equals mx plus b form to graph it. Because the asymptotes, really, if you have the vertices and the asymptotes, you can just draw a sketch. Now let's look at the equation. If we look at the equation y minus 4 and x minus 3, well, we see y's first, so we know it's automatically vertically oriented. And we see k is 4 and h is 3 because y minus 4, x minus 3, so we could plot our center right there. We see that a is 9, or a squared is 9, because that's a squared, so the a value must be 3. So we go 3 up or down, we draw our points there. And then we're already given the foci, so if we were given the foci on the equation, we could just do we could use our equation c squared equals a squared minus b squared to get that b as the square root of 7. Then we could draw our asymptotes. If you have the center and the asymptotes, you just draw like a curve from the center and progressively get closer to the asymptotes. Your teacher will likely accept that unless they're asking for something specific. Let's do one practice problem. Find the equation of a hyperbola with the vertices negative 3, 5 and negative 3, 1. But this hyperbola passes through the point negative 5, 7. So we see the center of the x and y's. We take the midpoint. The x value of the center is 3 and 5 negative 1 is 4 over 2 is 2. So the center is negative 3, 2. So we see that what changes here, the y value changes between the vertices. So we know it's horizontally oriented, or it's vertically oriented, because whichever way it changes, y is vertical, so it's vertically oriented. And we see that the center is negative 3, 2. The distance from that to the vertices is 3, so a is 3. So right now we have y minus 2 squared over 9 minus x plus 3 squared over b squared equals 1. But we also know it passes through the point negative 5, 7. So this is very simple, but it's sometimes complicated because you don't know how to use it in this situation. We just have to substitute in negative 5, 7. It's as easy as that. So we do 7 minus 2 squared over 9 minus negative 5 plus 3 squared over b squared equals 1. Because negative 5 would be we substitute in for x, and we substitute in 7 for y. 7 minus 2 is 5 squared is 25 over 9. Negative 5 plus 3 is 2. 2 squared is 4. So we have 25 over 9 minus 4 over b squared equals 1. We rearrange them. We subtract 1. And we subtract 1 from both sides and add 4 over b squared to one side, to both sides. So then we get 25 over 9 minus 1 equals 4 over b squared. 1 is the same as 9 over 9 because we have to get a common denominator. So 25 minus 9 over 9 is just 16 over 9. So 16 over 9 equals 4 over b squared. We multiply. 9 times 4 is 36. 16 times b squared is 16b squared. So we divide both by 16 to isolate the b squared, and we get b squared equals 36 over 16. So we can substitute that into our equation because we don't need b, we just need b squared. So our equation is y minus 2 squared over 9 minus x plus 3 squared over 36 over 16 equals 1. But when you have a fraction in the denominator or numerator in your hyperbola, you multiply so there's no fraction in the denominator. If we multiplied x plus 3 squared over 36 over 16 by 16, then we would no longer have a fraction in the denominator. So we multiply that part by 16, and we get our final equation, which is y minus 2 squared over 9 minus 16 times quantity x plus 3 squared over 36 equals 1. Okay, please like, subscribe, turn on post notifications. If you have any questions, comments, or concerns, please leave them down in the comment section below. Thank you to my math teacher, Mrs. Barrett, for teaching me this information. Please join me next time where we will discuss parabolas. I'm Scholastic Sam. Thank you guys. Goodbye. Always remember, knowledge is power.